All right, it's week 7 Friday. It's hard to believe. Well, I don't know, maybe it's easy to believe. This quarter seems like the days feel, I don't know. The days feel long, but the months have gone by quickly. It's hard to anyway, okay. We're still talking classes and object-oriented programming in Python. And in Wednesday's lecture, we looked at methods. And today we'll look at a few more methods, and we'll also discuss inheritance, which is a common thing that appears in the almost all kind of object-oriented programming paradigms. The idea of one class inheriting structures and methods from a parent class. And what we're going to look at here, we'll use the context of kind of a deck of cards, and to kind of get at this idea of inheritance. Okay, and so we're going to look at some I guess poker hands, and I don't know how familiar you guys are with the game of poker, but it works with kind of a standard deck of cards. I guess it's known as a French deck, and in each suit there's 4 suits: hearts, diamonds, clubs, and spades. And each of these, have a rank going from 2 at the lowest up through, 2, 3, 4 through Jack through 10, Jack, Queen, King, and Ace. I guess Ace can technically be on the low end or the high end, but it's often considered the highest. And so anyway, these are the different kind of poker hands that you can get, and whatever. It's here. So we'll take a look. Okay, so we've got 52 cards, 4 suits, and we will use, I guess we'll use bridge order. So if you play the game of bridge, which is this trick-taking game, they rank the suits in this order. Spades is the most valuable suit, and then hearts, then diamonds, and then clubs. Okay, and each suit has these ranks from ace to king. And again, ace can be put at the low end or the high end, right? And we need to be able to kind of represent a playing card, of which there are 52, a rank and a suit, okay? And how we should store the attributes. There's a lot of ways we can do this, but what we'll do is we will use a tuple, okay? And we will kind of encode the ranks to suits. So we're going to represent, rank, we'll encode the suits and the ranks, but the suits, we will say, if it's 0, that'll be clubs, diamonds will be 1, hearts will be 2, and spades will be 3. So we'll kind of use this 0 index, spades being the most valuable suit, we'll place it at 3, okay? And then for everything else, we'll kind of use numbers 1 through 10, Jack, Queen, King, okay? And so this is how we will define a class card. To kind of, when you define the class, you use a capital letter here, okay? And here we put in a doc string. And right now, the only thing that we have here is going to be the initialize method. Okay, so we have define double under initialize. And again, self is always going to be the first object in the method. And then we have 2 objects here, suit and rank, okay? And by default, we're going to put in 0 and 2. So this will be, by default, the 2 of clubs, okay? And so we're going to put, so when this gets initialized, it's going to take whatever value is in the suit. So when we call it, you can call it with 2 arguments. And it'll put a suit into self.suit, and I'll take the rank and put it in self.rank. Okay, and so the default would be the 2 of clubs. And so here we would represent the queen of diamonds as 1, diamonds being suit 1, and queen being the 12. Okay, so this card, so basically this is just going to be a card class object with just 2 values in there, suit and rank stored in there, okay? And this is how we could just kind of save this. Now, this doesn't actually tell us anything that it's the queen of diamonds. It just says self.suit is 1, self.rank is 12. Now, if we wanted this to be read by humans, okay, because here, let me just kind of let me restart the kernel here. All right, so if I restart and clear all outputs, okay. So if I do this and I say queen of diamonds here, and then if I just ask what is queen of diamonds, okay, all it does is this, okay? It just says this is the object, right? And if I said queen of diamonds, okay, this is still all we get, right? So there's nothing right now. There's nothing that allows me to kind of see what's inside there. Now I can do queen of diamonds suit, okay, and it will tell me it's a 1. So that's stored in there. And I can do queen of diamonds rank, and it comes back as 12. So the information that we stored, this 1 and the 12, is in here, but you know, this is not exactly easily read. And so what we want is we want to have, maybe I should add this to our to the notes. We want to have some way to read it easily. And so in order to do that, we need to have a string representation of the object. Okay, and so that's going to be the double under string method. Okay, and so here to do this, all we're going to do is we're going to say, you know what, print out, and we're going to have this vector of suit names. Okay, and we're going to, you know, if I, or not vector, I guess this list of suit names. And so if I kind of say suit names, give me, you know, suit names or rank names, and we say square bracket 0, then that will come back clubs, right? So if I say, here's this, you know, what's 0, or what's this, that will be diamonds. And then similarly, I have another kind of list. I've got a list of ranks. Okay. And we could say, all right, what's at the 12, right? And so this is basically a list of strings. And what we're going to do is, using the list of strings, we're going to just take the self.suit, and we're going to subset the rank names and the subset self.rank and self.suit to subset these things. And then and we feed those into the string, right? And so we're taking advantage of kind of Python's ability to kind of take values and plug them into strings. So I hope by now we're okay with kind of this %s or this %, you know, g or whatever % something to kind of take a string and insert, you know, values that we pass to it. And so this is how it's going to, you know, have a string representation. And so this is what we have, okay? And in order to kind of get this to work, I'm going to start my list of rank names, this list of strings. I'm going to start it off with none, just because the rank here, just to kind of prevent it from getting super confusing, you know, if it's rank 2, we want it to return 2. And because Python is 0 indexed, you know, we'll have rank 1, rank 2, up through rank 13. And there's nothing for rank 0, which we'll just keep as a none here. Okay, and so now if I define this, if I say card 1 is going to be a card from the 2nd suit of the 11th rank, that's going to come back and say this is the Jack of Hearts. And if I say card 1, 1, first suit, first rank, that's going to be the ace of, first suit and the 1 index. So it starts off at 0. 0 is clubs, 1 is diamonds, 1, 1 is ace of diamonds. And 3, 6 will be the 6th rank, which is the 6. And then the 3 is the highest ranking suit, which is the spades, 6 of spades. Okay, and so now we have card representations, or we have string representations of our cards. Okay, so here I have the 6 of spades. Okay, there is another special rank or special method called double under less than. And there's also double under, oh, didn't get updated here. Sorry, let me shoot, sorry, I just broke something. Okay, so this is good. All right, and so there is a special method, double under LT for less than. There's also another dunder method for dunder EQ for equality. Okay, and what this will do is it allows us to kind of allow us to use relational operators, right? So there, we saw last time for time on Wednesday, we saw a special method, double under add and double under right hand add, and that allowed you to use the plus operator with objects of this class. Now we can do, this will allow us to use comparison operators, greater than and less than, for our, to kind of compare these cards, okay? And so just, as far as ranking the cards, we are going to say suits are more important. We're going to say suits are more important than the ranks, okay, as far as ordering the cards, right? And what this will do is it'll kind of be like new deck order. When you if you rank the cards this way, it's going to put all of the spades together, then all of the hearts together, then all of the diamonds together, and then all of the clubs together. And those will all be ranked from ace to king, something like that. So this will be kind of like new deck order, rather than in some other games, all the aces are worth more than all of the kings, worth more than all of the queens, and things like that. So those are going to be so we'll keep it this way in terms of just saying the suits are more important. And for the comparison, we can do tuple comparisons. Okay, and so here we're going to create a tuple using just these numbers. Okay, we're not using the string representations, so we're not doing the rank name self rank. We're just taking the self.suit, which is a number, right, like a 0 or a 2 or something, and the self.rank, which is another number, and we're creating a tuple out of those. Okay, so we're putting the suit first and then the rank. So you have a tuple like 0, 2, or another tuple, 2, 4. And the way it does the comparisons, so Python knows how to compare tuples, and we're going to say when you use the less than operator between one instance of the card, so the less than operator has 2 arguments, the self and another thing, right? Because you're comparing one class with another class. You got the self and the other. So you do less than here, and this will do the comparison, okay? And then if you want to test equality, you run the same thing, double under EQ, and here I have the equal sign. And it's going to say this is how you should compare whether 2 instances of the card class are equal, or to compare them in terms of ranking them. Okay, and so here we have card 1 is going to be the queen of diamonds. Card 2 is the jack of hearts. Okay, and so the suit order is clubs are the weakest, then diamonds, then the hearts, and then the spades. Okay, and so in our case, all of the hearts are superior to all of the diamonds. So even though the jack is of a lower rank than the queen, it's going to be more valuable here. So we say, is card 1 of a lower rank, is the queen of diamonds of a lower rank than the jack of hearts? that's going to come back true because it's comparing the tuple, right? And so this double under LT, this double under less than, allows us to do these comparison operators. This is not something that just appears. Like if we didn't define that double under less than, Python would complain and say, I don't know what you're talking about. Okay. Here we can have card 3 be the queen of hearts, and we can compare the jack of hearts to the queen of hearts. We can say, is the queen of hearts a lower rank than the jack of hearts, which is card 2? And that comes back false. Okay, and then over here, I've got card 4, which is the queen of diamonds, or card 1 and card 4 are both the queen of diamonds. And we can say, are these things equal? And this will come back true. Okay. And if we say, is card 3 equal to card 1, that's going to come back false. Okay, let me pause here and give you your view quiz answer. I think I forgot to make today's view quiz answer visible. So let me just fix that up. Log in to CCLE. Okay, and today's first view quiz answer is the letter A. A as in apple. A. Okay. All right, so what we're going to do now is we're going to take that card and we're going to build up a deck. We're going to build a deck from that. So, so deck is made up of cards, okay? And what it's going to do is it's going to contain a list of cards as an attribute, okay? And so, so what we're going to do is we're going to initialize a deck, which is going to basically create the attribute that kind of has all 52 cards in it, okay? And then the string method builds a list of the string representation of the cards, and we'll do this, okay? So here's our deck, okay? And basically, as far as the deck goes, when you initialize a deck, you can't pass any arguments to it, okay? We're just saying init self, okay? Which means, and there's nothing, no arguments that deck accepts after self. So you can't put in any kind of, you can't provide any arguments when you initialize a deck, okay? And we start off by creating just an empty list, okay? Self.cards is an empty list. And then we have basically 2 loops, a nested loop, all right? So we say for all suits in range 4, which will go from 0 through 4, and then we say for all ranks in range 1 through 14, which goes from 1 through 13 and ends there, we're going to create a card, okay, using the suit and the rank here. And then we're going to take that card that we just created, and we're going to append it to this list here, okay? So this list is going to contain a whole bunch of instances of the card object, right? So we have to have the class card defined, and then we're going to create a whole bunch of them, okay? We have this double loop. There might be a more efficient way to do this, but this is okay for now, all right? And then how do we represent the deck when we say print out the deck, right? So we want to take the deck and we're going to print that out. And so what we're going to do here, okay, is we're going to kind of create an empty list again. This would call res for results, okay? We create an empty list of the results. And what we're going to do is, now that the deck has defined kind of all 52 cards or whatever cards are in self.cards, okay, we are going to go for every single card there. We're going to have a string representation of the card, and we're going to append that to the list, right? So I could have said print, or, we have the string operator. The card has a way to represent cards as a string. So we're going to say represent the card as a string, append that to the list here. And then what it's finally going to do is it's going to return a string, where all of the values inside the list are joined together using the new line operator. Okay, so the dot join will take all the contents in a list and it will join them all together using this operator here. This is a string operator, so dot join. Okay, so we'll go ahead and generate a new deck, but just by calling capital D deck to create an instance of the deck. And then we can say, print out the deck, and it starts off and it goes ace through king of clubs, ace through king of diamonds, and it keeps going ace through king of hearts, and then ace through king of spades. Okay, and it basically creates a deck of cards kind of in new deck order. Like if you buy a fresh pack of cards, it will probably be in an order much like this. All right, is that okay? Okay, and so because we've defined all of these special methods, right now we have just an init, and we have a string representation for the deck, but within the cards we have a string representation and then a less than operator and things like that. Okay, we can also, well, we'll go ahead and add methods to the deck. Okay, so to kind of deal cards, what we want to do is we've got, the deck of 52. What we're going to do is we're going to take a card and we're going to remove it from the deck. So we can so right now the cards are represented in the deck as a list of card objects. And so what we're going to do is we're going to just pop one of the objects out of the list and we're going to return it, right? So here we're going to create a method called pop card, and we're going to say take self.cards. This is a list, and the list is full of card objects. We're going to just pop. Okay, now that's going to do that, right? If we want to add a card to the deck, we can say add a card. Okay, and we use the self. All methods have call it self, and then but this one we want to add some kind of object here, and we're going to do basically a card object here. This is just arbitrarily named, and we're going to say to the self.cards, again, cards is the list of cards. We're going to just append another card to that list. Okay, we can also shuffle the deck. Okay, so we can shuffle the deck, and we can call random.shuffle, which is basically a method that will take a list and just shuffle the contents of the list. And so we're going to say do random.shuffle, and we're going to just basically shuffle the self.cards. Okay, that list self.cards. Okay, and this is a key thing, is that we have this less than method defined for cards, and because we can now use less than, which is useful as far as like ordering our cards and putting them in order, we can actually sort our list of cards. So inside the deck we have a list of card objects, and we can sort that list of card objects. So we can create a method called sort, and it's going to sort itself. And what it will do is it'll take the cards list, self.cards, and then we can call sort. Okay, and sort will work. Sort, in order for this sort method to work, we need to have a way to compare the cards, and we do because we've defined the double under less than. Okay, random.shuffle does not come from NumPy. Random.shuffle is Python does have kind of a built-in random thing. Yeah, so the less than, there's no greater than. Yeah, so the less than, it figures out for greater than, it just kind of swaps the other and the self. So you can do that there. Okay, so this is what we have here. We have the deck. We've got the initialize method. We have the string representation method, and we've added these methods: pop card, add card, shuffle, and sort. Okay. All right. So here we'll create the deck. Okay. And we can ask, what's the length of this list, deck.cards? There's actually another double under method, a dunder method for length, which you can just say length of the deck. And then you could say, when somebody asks length of an object, what should it return? and you can basically say just return the length of deck.cards, but here we just got, we can call it directly, what's the length of deck.cards? Print out the deck, okay? And we can say, all right, take the deck and we'll shuffle it. And let's go ahead and just kind of print that out, okay? And so here I just said print the kind of the first 100 characters. And so, it just kind of, it says 2 of clubs, 2 of diamonds, 10 of spades, jack of diamonds, 5 of diamonds, 3 of diamonds, 5 of spades, ace of something. But I just said the first 100 characters, just because, yeah, that was simple. And then we say the last 100 characters. And so this is just what the deck looks like when we've shuffled it, okay? We can say, remove pop a card. So that's basically dealing. We're just going to deal the card at the, I don't know if this is the top or the bottom of the deck, but it's at the end of the deck. So this is kind of like dealing from the deck. Okay. So we'll pop a card and we get back the 10 of hearts. We pop another card and we get the 8 of hearts, and you can kind of see these, and then we'll get the 8 of clubs, king of spades, king of hearts. Okay. And so we can say, how many cards are left remaining, and we can say, oh, there's 50 cards left. And then when we check, the original, the deck's in the same order, we've just removed these cards over here, right? So it still starts off with the 2 of clubs and 2 of diamonds. Those are still kind of, I guess, if you're listing them off from the bottom to the top or something. Okay. All right. So that's the deck. Does that feel okay as far as all of this? Let me go ahead and give you your second view quiz answer for today. Second view quiz answer is D. D as in dog, or diamonds, or a deck of cards. D. All right, so now what we want to do is we want to kind of create another class that inherits from the deck class. Okay, so it's kind of like a special version, special case of an existing class, and that's where inheritance comes in. Okay, so what we can do is we can have a class that represents, say, a poker hand, right? So poker hand, or just a hand of cards. So if you're dealt a hand of cards, that's what we can have, right? So we'll assume, I don't know, whatever you want, right? And so a hand is kind of like a deck, all right? They're a collection of cards, and you also need to have the ability to kind of like add cards and remove cards, but there are operations that we want for the hands that don't make sense for the deck, okay? So for example, in poker, we might want to compare 2 hands to see if one wins, okay? Or, if you're playing bridge or something, you might want to be able to compute a score for a hand, or something like that, in order to kind of, make bids and bridge and stuff like that, which is a complicated process. And then, so anyway, this relationship leads to the concept of inheritance, all right? And basically, you're going to do that, all right? And so here, what we want to do is we want to define a new class called hand, okay? And we want to say that it inherits from deck. And so the way we do this is we define the new class hand here, and then we put the class that we want to inherit from deck inside the parentheses here. Okay, hang on a second. Okay, so we want to inherit from the deck class. So we put class hand deck here. Okay, and so so this means we can inherit the methods like pop card and add card, those get inherited from the parent class. Okay. And if we have nothing else defined, then hand will also inherit init, which is the initialize method. Okay, but we don't actually want to inherit that thing, right? Because a deck, when you initialize a deck, is going to generate 52 cards, and we don't want that. Okay, so what we're going to do is we're going to create a new initialize method, and that's going to kind of override the method from the deck. All right, and so so here we're going to create a method here, and basically any method that you have that you define here is going to override any methods that already exist in the parent class. So we're inheriting from deck. Deck has its own initialize, but we're defining our own initialize method for the hand, and this is what it's going to look like. Okay, so right now our initialize method starts off with an empty, basically an empty list for self.cards. Okay. And then the hand also comes with a label, all right, which by default is blank, but maybe we want to add something to that, okay? And so if we create a new hand, we can say hand, new hand. This is the label that we're passing it, okay? Hand.cards is basically an empty list. Hand.label is this string that we passed to it as an argument, okay? Because that's, here this allows for, one argument to be passed, and that's going to be the label. That's what we have. Okay. And so what we can do is we can kind of join these things. We can say, all right, create a new deck. That's going to be deck. And from the deck, pop a card and take that card. And then we're going to add that card to the hand. Okay. So hand inherits the add card method from the parent class deck. Okay, and what we're going to do is from the deck, we pop the card, and that card now gets added to the hand. Right, and so now I can say, all right, what does my hand look like? Hand also inherits the string representation of the deck deck class, and so the card that got added to the hand is the king of spades. All right, and so what we can do is we can kind of create, add some more complexity to the deck class. And what we'll do is we'll create a function called move cards, okay? And what move cards, this is a method that belongs to the deck class. What we're going to do is we're going to move cards from the deck to some hand that we provide it, and some number of cards that we want to move from the deck to the hand. Okay, so we're going to say for I in range number, we're going to basically pop a card from the deck, and we're going to add that card to the hand. Okay, and we're going to do it range number of times. So we're going to do it whatever number we put it. Okay, so that's going to move 5 cards from the end of the deck into the hand. Okay, we could probably create another method that will take multiple hands and do some kind of dealing operation. And so when you deal cards, you don't take 5 cards off the top and give it to the first person, and 5 cards next and give it to the next person. You have to give 1 card from the top of your deck to each person that's being played, right? And so that would require, a slightly more complicated definition, but you could create a method that accepts multiple hands as an argument, and then kind of cycle through kind of the dealing out of cards. But right now we're just going to keep it simple, and we're just going to move cards from the deck to another, right? So anyway, that's what we'll do. Okay, self. So here, self is a deck class, but again, because hand inherits from deck, this move cards can actually be a hand as well, right? So cards are moved from one hand to another, or a hand back to the deck, and that's fine because self can either be a deck or a hand, okay? Despite the names that we're using here, okay? And so inheritance is useful. Something that would be really repetitive without inheritance can be a lot more elegant when we use it. Okay. And so anyway, it's a great thing to have. Okay. And, inheritance often reflects the structure, natural structure of the kind of the problem that we're thinking about. But at the same time, it can also become more complicated. And so, just be, I guess, be careful, and you want to think carefully as you're trying to design your approach or your solution to the problem. All right, so here is our deck class. As it gets more and more complicated, we've now added a method for moving the cards. Okay, so we have all of these other methods. Okay, so now we're going to create an empty deck. We're going to create a brand new hand. Okay, or not an empty deck, a new deck, which has 52 cards, a new hand, which currently has nothing. And we're going to move 5 cards from the deck to this hand here. Okay, and we say, okay, what is in the hand? All right, and so remember, when we initialized the deck, it was put in kind of new deck order. And so when we move 5 cards over from the deck to the hand hand now just contains almost a royal flush, just one rank shy of a royal flush. It goes the 9 through the king of spades rather than the 10 through ace of spades. Okay, so we have that. We can say, all right, let's create a new deck and a new hand. What we can do is we can shuffle the deck. Okay, we'll shuffle the deck and we'll just look at the last few cards here. And the last few cards in the deck are basically these: the 8 of spades, 10 of hearts, 4 of spades, queen of diamonds, jack of clubs. And we're going to say move 5 cards from the deck to a hand. And when we do that, the 5 cards in our hand, because basically we just dealt them off the top or the bottom of the deck, however you want to look at it, into the hand. Okay, and then now if we look at the kind of the last few cards of the deck, okay, last few cards of the deck, we have the ace of spades and the 3 of diamonds, right? And whatever this is, the something of clubs. Okay. All right, and so there is basically, we can show relationships between these hands, and I messed up my slides here. But at this point, what we can do is we can kind of start, you might have to diagram how the classes are related, right? So objects in one class might contain references to objects of another class. So for example, when we created the class rectangle, it contained reference to a class point, okay? And when we create the class deck, it contains references to class card, all right? And so this kind of relationship we call it has relationship. A rectangle has a point, a deck has a card, right? And then you have another type of relationship between classes where one is a special instance of another, right? So one class inherits from another, and this would be an is relationship, an is a relationship. So a hand is a kind of a deck, like it's a miniature version of the deck. So basically a deck being a pile of cards, and a hand is basically a miniature or some version, it's another pile of cards basically. Okay. One class might depend on another in the sense that the objects in one class take objects in the second class as parameters, or use objects in the second class as part of some kind of computation, all right? And so those things would be dependencies. So if you take this hand that we've created, right? So here's our hand: jack of clubs, queen of diamonds, 4 of spades, 10 of hearts, 8 of spades. Keep in mind, the hand is basically an object where one of the things inside the object is a list, and it's a list of card objects. It's a list of card objects. And so if you can ask basically the contents of a hand, and you'll get back this dictionary of basically all of the things, all of the variables stored inside the hand. And it says, okay, you've got one variable called cards inside hand, and cards is a list. And if you look at that list, the contents of the list is, a card object, another card object, and it's basically 5 different card objects, right? So we have in 5 instances of the card object, okay? Hand also contains another variable called label, and that just contains a string called new hand, right? So it's a list of other card objects. And so, you probably won't be looking at this very frequently, but this also gives a sense of what is happening here, and that the hand is not just a string representation, but it actually contains other objects in it. Okay, the last bit is just a little bit of extra text. Okay, and it says, here's a design suggestion. When you override some kind of method, the interface, in that the way somebody uses the method, the way you use the new method should be the same as the way you use the old method, in that it takes the same parameters, returns the same type, and obeys the same kind of preconditions and post conditions. Okay. So for example, when we talk about creating some kind of method for less than, the less than operator, it should work in some kind of way where you put in one object and another object, and it performs a comparison and it returns a true or false. Okay. And that would be what somebody would expect, right? When somebody puts in a less than and you do like, it's 3 less than 5, you expect it to return a Boolean value true. Okay. And if your version of less than has a different interface, as in like it does something different, it takes in, different types of objects and returns different types of things, it's going to be confusing for the users and for yourself when you're trying to read your code, a couple days later, a couple weeks later, trying to understand, right? And similarly here, when you're working with some parent class like the deck and the hand, or maybe you design some special version of the poker hand or something like that, when you say something like, if you have common methods like add a card or shuffle or things like that, pop card, those should all work the same way across all of the different versions and instances. Otherwise, it could get confusing. Okay. All right. I think we'll end it here for today. Let me give you your last view quiz answer for the day. Last view quiz answer is B. B as in bear. B as in bear is your last view quiz answer for today. And that will be it. Okay. Oh, I have to talk about DataCamp. There was some confusion about what's happening with DataCamp. And so let me, so I apologize, and I messed up because I didn't, this is my first time. Oh, geez. Okay. Give me a second. I gotta get signed in here. Okay, so I said earn 2000 XP, okay? And so the way this is gonna work is you go to DataCamp, you pick basically any course, all right? And so, I recommend picking some kind of Python course that's of interest to you. So you can pick any of the courses here. And you just, you come over to courses, you do filter, and then you can choose Python or, whatever else you're interested in. So technically you can do any of these things. I recommend Python. You're in a Python class. Okay. And then basically you say, oh, you know what, this sounds kind of interesting, right? Introduction to whatever, data manipulation with pandas or something like that. Some of these I've already done, so this is replay course, but basically you'll just, you'll click this and then you'll start it off. You'll do this. And then as you do these things, okay, you will earn XP, okay? And all you have to do is earn 2000 XP. 2000 XP is approximately 2 chapters, okay? So a course one full course. This course will award 3,700 XP. This course awards 4,700 XP. So 2,000 XP is something around 2 chapters in a course, okay? And that's all you have to do. Now, I messed up, and what I wanted to do was have you earn 2,000 XP by the end of next week, which it says 8 days. So by basically Saturday the 22nd, I want you to earn another 2,000 XP by the following week, and another 2,000 XP the following week. Okay, so I just wanted you to do 2,000 XP each week. So I created all 3 of these things, but apparently, once you earn 2,000 XP this week, it counts it simultaneously for all 3 weeks. So all 3, like once you earn 2,000 XP, it's going to fill this in and fill this in. So what I have to do is after this assignment ends, I'm going to have to create another earn 2,000 XP assignment, if that makes sense. Okay, so I'll do that, and so you'll just see the same assignment pop up again. And I hope this is okay. You get to just pick whatever chapters you want to do, and so some of you have already gone ahead and done other things. You just have to do 2 more chapters this week, pretty much. Okay, and maybe a little bit more than 2 chapters, or a little bit less than 2 chapters, whatever it takes to get to 2,000 XP. It's approximately 2,000, 2 chapters. Okay. Any questions on that? How the data camp assignment works? So there's no specific course that I've assigned. You just kind of pick one that seems interesting to you. You can also do the daily practice. Daily practice gives you XP. And then you can also go to the projects library, and the projects library also gives you XP. But probably the easiest and most straightforward way to earn XP is to run the courses. Okay, well, with that, we'll call it a day here. Have a good weekend, you guys, and we'll see you guys on Monday.